Hello everyone. Today I want to solve question 2042, valid anagram. Given two strings s and t, return true if t is an anagram of s and false otherwise. And what is the anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Here we have two examples. The first S for the first example is anagram, and the second word is Nagram, and we should return true here. And we have another example that S is RAT and T is CAR, or rat and car. So we have different solution for this question, and the for the first one we can only sort S and T and then check all of the character at the same index, and if the character at the same index are same as each other, we finally return true for that. And if we don't have if the sorted character are not same as each other, we definitely return false here. So for example, for the first one, if we sort S, we have A, and then G, and then M, and then N, and then R. And for T, we also have the same order. And we can see these two are exactly same as each other, character by character. A is same as A, and then G, then M, then N, and then the time and space complexity for this solution. We need to sort S, and we need to sort T. So S and T, and for each one we need n log n, which n is the number of the character in our string S and T. So overall the time complexity is this 2, which equal to O of n log n. And for the space complexity, we need O of n to save the data for the sorting function. So this is the time and the space complexity for this part, and writing the code for this is so easy. We can at the first step check if length of S is not equal to the length of T, we return false, and then we can return sorted of S equal to sorted of T. So let's go with the second solution. We have another solution for this question, and we can build one dictionary for S and one dictionary for T. So here is the dictionary for S, or hash map for S, and here is the dictionary for S and T. So we will go through all of the character for the S and T, and by end of that we compare these two dictionary to each other. So for the word S, we have anagram, and we can see we have one character A here, and we count that character, that is 1. This is the index, we only count the first index. And for the T, the first character is N, so we put here the count of N as 1. So we go to the next character, that is that for the anagram word we have ana. So this is the second character, and the second character is N, we put that in the S dictionary, and same for the T dictionary. And then the third character in S and T, for S we have ANA, so the third one is A. We already have the A in our dictionary, so right now A is 2, the count of A is 2, and count of N is 1. And for the word T, the third character is G. So we then move to the next one, and we can see that the the next character in anagram is G, and we put number 1 for this character, and for T we have character A, so we add 1 to the previous one here, and it changed to 2. And then for the next one, we can see that the next character in S is R, we put 1 for R here, and same for the T. And then we reach to the 5th character here, so ANAGRAM, and right now we are here. We have 3 A until now, and we put A as 3 here, and we have 1 G here, we have 1 N here, and we have 1 R here until this one. So, and then we move to the last character that we have, and we see that the last character here is M, and we put 1 here for M. So by end of this character, we can see that here we have A as 3. Okay, so let's choose another color here. We have A as 3, and here A as 3. So these two are equal to each other. We have N as 1, N as 1. So N is same. We have G as 1, G as 1. We have R as 1, R as 1. And we have M as 1 in the S and T. So finally we should return true here, since the dictionary of S and T are exactly same as each other. Let's go to another example here. So for the example, I think that we have rat and car here. So we can again build 2 dictionary, and at the first step we have R, we put 1 here for the S dictionary, and we put 1 for C in the T dictionary, in the T dictionary, and then for the next one we have A and A in the T, and for the last one we can see that in the S we have T, and in T we have R, so CAR RAT. Okay, so let's to check here. We have 1 R here, 1 R here, we check it. We have 1 A here and 1 A here. We have 1 T here, and we don't have any T here, so this is not true. And for this we should return false. Okay, so that's it. What is the time and the space complexity for this solution? For this solution, the time and space, for the time complexity, we have to go through all of the character in S and in T. So we have O of N plus O of N. This is for S and this is for T. That is O of N, which N is the number of the character in our S or T, and or we can write this in this way, O of N plus N, which is O of N. And for the space complexity, we have 2 dictionary, and each dictionary has N character. But based on our question, if all of these characters are in English and we don't have any number or the other special character, this is O of 26 plus O of 26, which is O of 1. But oral, we should say that is O of N, which N is the number of the character, number of the unique character in S or T. So yeah, that's it. And let's go to write a code for this solution. Okay, so let's solve this question with the second solution. And as we already discussed, if length of S is not equal to length of T, we can say that these 2 words are not anagram to each other. And then if the length of these 2 words are same as each other, we should build 2 dictionary or 2 hash map, and then populating these 2 dictionary, and then compare the dictionary and if they are exactly same as each other, we should return true. Okay, so let's count S and count t, and then for each one we can go to s and say count s of character c equal to count s get c and 0 plus 1. And the way that this function get works is, if we don't have that character in our hash map, this function will set that to 1, and if we have that character in our hash map, we add 1 to that previous value. For example, for the anagram word here, at the first step a is, we don't have anything at the first step, this is empty, and then we have a, we set to 1, and then it changed to a to 1 and n to 1, and then when we reach to the second a, we already have one a there, so we set this to 2 and n to 1, and go on. So for the second dictionary, we can go to t and do the exact same thing for the second dictionary, and by end of that we can return true if these two dictionaries are exactly same as each other, and if not, the code return false for us here. Okay, so what is the time and space complexity for this solution? For the time complexity, we have one loop for s, that is O of n. We have one loop for t, that is O of n, and overall this two is O of n plus n, which is O of n, which n is the length of the s or t. And for the space complexity, we have one dictionary for s and one dictionary for t, which is O of k plus m, which k is the number of unique character in s, and m is the number of unique character in t. So in the case that we have only English character, this is O of 1, since we only have some limited number of the English character. And in the case that this s and t contains the different and special character, this is O of k plus m that we already discussed. And in the case that they are anagram to each other, this is O of 2k or k, since k and m are exactly same as each other, but consider a scenario that s is a and t is, I don't know, maybe this, something like this. So in this scenario, these two are not same as each other, and the space complexity is not O of 1. So that's it. Thank you so much.